Today we are talking about something that is in everyone's lives. But still, most of the people don't even know it is there. And a lot of those who know don't really understand it. So what are we talking about? We are talking about databases. You know, these huge things that are needed to save all the data we produce and use. So be it on YouTube, as you are now, or Instagram, or Facebook, or basically everywhere else where you have a computer or mobile phone and you use some data to work with, they are mostly stored in some sort of database. And as databases are still growing and even more data is used and stored in databases, I think it's pretty easy to say that databases play a huge role in our today's lives. So I want to tell you something about databases, how they work and what they are. So stay tuned and enjoy. So the first question we have to ask is, what are databases? Databases are basically file storages or data storages. So in the early times of computing, data wasn't a big deal because there wasn't that much data, but now in the times of the internet and with all the IoT stuff, there is more and more data and we need to store them somewhere. And databases are basically just a simple file storage. So you have probably seen some graphic like that. This is the typical symbol of a database. And as I already said, databases are basically just a huge collection or huge collections of data. So all the data we have in the world are mostly stored in databases. Then the second question we need to ask is, why do we need them? Well, as you probably guessed, we need them to store data. Well, that's obvious. And we have ever-growing data masses, so yeah, it's pretty good to have them around and make them store our data. The second point is that in the early times, we used files to store our data. So in the early times of computers, there were only files like a simple txt file, and we use them to save our data into. But if you have data that contains, I don't know, 10 million lines of text, then a simple text file doesn't cut it anymore, and if you want to get through it and work with it, a simple text file is reaching its limits very fast. And also, databases are very good to store their data for a long time. So if you want to store data not only for 5 minutes, but for, I don't know, 10 years, which is the case in some companies, because they have to store their data extremely long because of legal issues and stuff, they use databases to archive their data. And databases make the work with data efficient. They have tools and a storage system that makes working with data extremely efficient, even if there are huge data masses. So if you have a simple file and it gets too large, maybe you've done this before, opened a .txt file or a Excel sheet, and this file is so big that your computer starts to slow down. With databases, most of the time that isn't the case, but even databases have a limit. So now I want to tell you something about the history of databases. Well, as I said before, in the early times, computers didn't do much. They were used to compute, basically. That's what they do. They used to do calculations about some math problems or stuff like that. And this was around or before around the 1970s. In the 1970s or so, around this time, it's not clear what date it was exactly. After that time, the data grew because computers got more powerful and we produced simply more data. We used them for more stuff like gaming at some point. And so the amount of data grew and we needed better storage. At first we used files, but then files quickly ran out of capacity, so we needed databases. And that's when we created databases. So in the beginning of the database age, we had hierarchical databases. And hierarchical databases look kind of this one at the top here. We have this root data point, and from this downwards we have childs at different levels. So you can structure it like a tree. And today we have so-called relational databases, mostly. So we have other databases, but mostly relational databases that look like that one down here. I'm going in depth of relational databases in a few minutes, but just know the structure. It's different than hierarchical databases. So, as I said, there are not only relational databases, but they were, after the hierarchical databases, basically the first, and now they are the most used form of databases. But we have types like objective, deductive, and lots of data types more, but they are not that common in use. So, yeah. And, well, I guess the future, it brings more efficiency with huge data masses. Today we are already running in the tera or even petabyte amounts of data, so it's huge already, and we need to get more efficient with those data masses. So probably databases are getting even more efficient than they are already. A second point I think that's coming in the future are mobile databases, because life changes or swifts even more to mobile as smartphones grow stronger and are getting more computing power. I think there are more and more databases that are suitable for mobile, and we can use them on our phones directly. And a third point is data security. I think data security is increase in popularity as awareness for this topic grows. Already in the EU, it's a huge topic with data security, and I think in the coming years it's growing even further. So now I'm gonna show you how relational databases are built, or how they are structured. So I've showed you this picture before, and you can see here in this picture that we have some tables. Those represent tables basically, and they are connected to other tables. So when we start at this pupil table, we have a name of the table, which is pupil, and we have some attributes or columns, that is pupil ID, first name, surname, gender, house ID. Behind each of those columns you can see the data type they have. So pupil ID is the integer, first name is a string, surname is a string, gender is a char, house ID is a char. So you can imagine this as a table. So we have the columns like go down there, and then we have entries for each of those things. Then this pupil table is connected to the house table, which you can see by this house ID. So we have the house ID here and the house ID here. And what we have now is the house ID in this table is a primary key. The primary key is an identifier which identifies each entry in your table. It basically identifies each entry in your table. So a primary key can't have duplicates. So this house ID is not a duplicate, never, and it's the primary key in this house table and a foreign key in the pupil table. So now if you have a pupil, take out the pupil, you see, okay, if I take this house ID and go to my house table and look for this house ID I got from the pupil table, then I get my house name and the head of the house. And so this works with every other table around here. So we have the pupil ID, which is connected to the attainment, which also has the pupil ID. Then we have the first name, which is a string, and is connected to... we have the pupil ID again, which is connected to the teaching class as well. Here we have the pupil ID, And from teaching class going on, we have employee and department connected, and we have course and subject connected. But beware around here, the teaching class is only connected to employee and course and pupil. So the subject is not connected to teaching, it's connected to course. And the department is connected to the employee, not to the teaching. So the relational in relational databases comes from those relationships you have here, those connections of IDs, and so primary and foreign keys. And that's basically why it's so good to have these databases, because you can model everything or almost everything in our daily lives into a relational database. Yeah. So now, after I've shown you how relational databases work, just a quick overview, I think I'm gonna do a video more in depth about relational databases soon. I want to show you famous database products and companies. Remember, I'm not sponsored by any of those, I'm just telling you which are the most famous. Some of those I even use myself, and yeah. So the first we have Oracle, which is produced by, so it's an Oracle database, which is produced by the company Oracle. Oracle has multiple databases, but yeah, I think there is one called Oracle. Then we have the database MySQL. MySQL is, the name is abbreviated from SQL, which is the structured query language, which is used to build databases. So if you heard of SQL and know SQL, you can basically work with databases, relational databases at least. And MySQL is a database based on SQL, and it's developed by the MySQL AB. The next product I want to show you is our Microsoft SQL Server. This is a database also working with SQL, and it's developed by Microsoft. Then we have PostgreSQL. It's a open source database. MySQL is also open source, but it's developed by MySQL. Still, if you want to develop with, or if you want to help develop MySQL, you can do this by going to MySQL, the website, or to the GitHub repository. PostgreSQL is the same as is also open source. You can also help develop them, but it's basically developed by PostgreSQL Global Development Group, and I think they both have a support. So MySQL AB and PostgreSQL Development Group are offering a support for their databases. The next one is MongoDB. It's also a open source database, which is developed by the MongoDB Incorporated. It goes the same as for PostgreSQL and MySQL. You can help develop them if you want to. And I think support is offered by MongoDB, but I'm not sure on the support part. The last one I want to mention is IBM. IBM is a global computing or software company that is also offering multiple databases where you can get support and databases. Yeah, so this is a quick overview about databases, where they come from, why we need them, and what companies offer them. If you have any questions on the topic databases, please write me in the comments. I'm trying to answer them as soon as I can. And I hope you enjoyed the video. See you next time. Bye.